Hello and welcome. If you are watching this video, you have most probably heard of and learned about SOHCAHTOA. SOHCAHTOA actually is a formula, and it contains three smaller formulas in itself, which describe the primary trig ratios, we say. Now, just to recap your memory, if you are in a right angle triangle, and you mark one of the angles in the right angle triangle, we say that the sine ratio of that angle would equal the side opposite to it over the hypotenuse. So divided by hypotenuse. The cosine ratio would be adjacent over the hypotenuse. And the tan ratio would equal the opposite divided by adjacent. So knowing the relationship between the ratios of the side lengths and their angles, we can use the SOHCAHTOA formula to determine or to find the values of side lengths in a right angle triangle or the measurements of the acute angles. We always know this is 90. One thing that we emphasized was that we must always use SOHCAHTOA if we are applying it in a right angle triangle only. So now the question becomes, how about non-right angle triangles? How do we solve them? And can we use the relationship between side lengths and the angle in non-right angle triangles? And how would that work? So there are formulas that we use in non-right angle triangles. There is two of them. And the first one we're going to look at is the sine law. The sine law formula indicates or states that if you are in a non-right angle triangle and you label the angles by uppercase letters A, B, and C, then got to make a point here. So angles A, B, and C are different from each other. And then we label the side lengths of the triangle by lowercase letters A, opposite angle A, lowercase b, opposite angle B, and lowercase c for opposite angle C. Now we're going to say that the ratio of the side A divided by the sine of angle A would equal the side B divided by the sine ratio of angle B, and that will equal side C divided by the sine of angle C. Now, how do we understand this formula? We can do an investigation for sure, but a simple way of explaining it is the fact that the bigger the angle, and then the bigger the side opposite to the angle, so the ratio will stay constant. The smaller the angle, then the smaller the side opposite to it. And that happens to maintain the same ratio between angle and side length. So here we go. I'm going to box up the formula, and this is what we call the sine law. Now remember that the sine law can be written in two different ways. So we can write it as A over sine A equals B over sine B, C over sine C, or we may also write it as sine A over side A equals sine B over side B equals sine of C over side C. And that's for the sole reason that if we say, for example, 1 over 2 equals 3 over 6 equals 4 over 8, it's the same as if we're saying 2 over 1 equals 6 over 3 equals 8 over 4. And that's why we look at it both ways. I usually like to focus on one of the formulas because the other one, it's easy to derive it. Now, how do we use the sine law when we are solving or when we are working with non-right angle triangles? Step 1 will always be to label each side of the triangle in relation to the angles opposite to it. So the same thing that we did before here with this triangle. So this is what we have in this case, a triangle A, B, C, and opposite angle A, we have the side length A. opposite angle B, we're going to label the side as B, lowercase, and opposite angle C, we're going to have the side length C. The next thing that we want to do is write out the sine law. That's your step 2. So A divided by the sine of angle opposite to it equals B over sine of B equals C over the sine of C. Step 3, we have to substitute all the given information. And here I want to add something. Examine the diagram and see what we're given. We know one side, and then we are given 2 angles. Whenever you're given 2 of the angles, you know that it's easier to find the third angle, and you don't need any laws for this, like, for example, the sine law or the SOHCAHTOA. So none of the trig knowledge that you have acquired so far. For this, you simply use the sum of interior angles in a triangle. The more information you have in the problem to start with, the easier it will be for you to see what solution to or what approach to take to answer or to solve the problem. So in this case, since I'm given 2 angles, I am gonna jump on to finding the angle B, and I'm gonna say that angle B equals 180, take away 48, and then take away 37. So that would equal 43785, so 95 degrees for angle B. And I will write it down here on the diagram. It's easier when we plot everything on the diagram because we can connect things together more easily. So now I would say that I am ready to substitute the given information once I found this small piece of information that was hiding, and it was so easy to kind of disclose in some ways. So here we go again. So we're going to say A is unknown. That's what we are asked to find. The sine of A is sine of 48. And that equals B, which we know is 24 right here, divided by the sine of B, which is the sine of 95, equals C, which we don't know, divided by the sine of angle C. So now we're thinking, what are we asked to find? We are asked to find the value of A. And where is the value of A in the formula? I'm going to say it's right here. And now we're thinking again, okay, so if we want to find A, we must use this ratio. Remember that the Sine Law Formula has 1, 2, 3, so it's like a double equation. And we don't need to solve double equations. We have to use only part of it in order to find the unknown. So we are going to say that we are going to have to use A over sine of 48 because we need to find the unknown A. Now, what's the next ratio that we can use? We have 2 more in here. Would it be smart to use 24 over sine 95? Or would it be smart to use C over sine of, actually, we have C here, 37. So we're going to say, well, if I use C over sine 37, then I will have 2 unknowns, so I can't use this part of the formula, at least not now. Okay, so we're only going to take 24 over sine 95. And from here, you simply cross multiply because we have one fraction in each side of the equation. And this will be the case, actually, in most problems that you solve with sine law. And here we go again. We're going to go ahead and cross multiply. So A sine 95 equals 24 sine 48. And one thing that I like to remind myself always is when I multiply the sine of an angle by a number, like in here, I always put the number first and then I write sine 48 at the end. The reason I like to do that is because sometimes when people write sine 48 times 24, now you either have to put brackets around here, okay, or simply bring that 24 in here, because if you forget to put the brackets, which is the case very often, Now, this looks like an angle and it changes the value of the term, so you don't want to make that mistake. You're going to get the wrong answer. Now, we need to isolate A, and A is with or multiplied by sine 95, which means we must divide by sine 95 both sides. Here we go. Get rid of sine 95, and we have A equals 24 sine 48 over sine 95. And when I find the answer, I just complete or perform the calculations in one step. I do not want to round the numbers sine 48 and sine 95 and substitute and then find the answer, because then I'm going to base my final answer on many rounded numbers, so it would be far from the most accurate answer. So I'm going to go to my calculator and find 24 sine 48 over sine 95. So remember that your calculator must be in degree mode, times sine 48. And remember that here you got to put the brackets around sine 48. If not, then the calculator will do funny things with the division, okay, over sine 95. Okay, and now we can divide. We get 17.9, and 17.9 would be the length of A. So we're going to say that the length of A is 17.9, don't forget the unit measurement, centimeters. And I usually, if you've noticed, I like to box my final answers so they stand out. And sometimes even the information that I find on the way, so that I can find it more easily. Now, let's say that this question didn't ask you just to find the value of A. Let's say that the question asked you to solve the triangle. You know that to solve a triangle means to find out everything about it, so all the side lengths and all the angles. In this case, we have all the angles. We just found one missing side, so you would have had to apply the sine law one more time to find C. We're going to leave it there. If you want to do it for yourself, practice it. That's good practice for you. Now, the next question is an example where we have to find an angle. Again, we have a known right angle triangle. And as we did in the previous question, we are going to start by labeling each side of the triangle. Examine what information you're given. So we are given one angle, 58 degrees, one angle which is unknown and we need to find it, and another angle which is unknown. So I always keep I try to stay alert and think, oh, can I find the third angle? That's not the case because we're only given one. So that's what it is. And then I'm going to label all the sides in relation to the angle opposite to it. So that's lowercase p. This would be lowercase n. Remember that we must use respective letters, right? And lowercase m. Now, in this case, my sine law would look like this. M over sine of m equals lowercase p over sine of p equals lowercase n over the sine of angle n. Next step, substitute all the information given, and I have the length of m, 35. The angle m is unknown, so I'll write sine of m. The side p is also unknown, and angle p is also unknown, so I'll write sine p. The last one is side n. Side n is 42 over the sine of angle n, and angle n is 58. So there we go. So remember that we need to find the angle m, and angle m is right here in this fraction, which means that we must use this fraction right here, or this ratio. And then we travel along the sine law formula, and we check and see, can we use this? Well, we know neither numerator nor the denominator, so that's a no. And when we check the last ratio. We see we have both of them, which means that we are simply going to use those two ratios, connect them together by the equal sign. 42 over sine 58. So again, as I mentioned before, we are using cross multiplication very often, especially with sine law, because we end up having one fraction in each side of the equation, which is kind of nice in a way. So another thing that I like to do usually, because I like my variables to be in the left side of the equation, first I multiply do the cross multiplication that connects the unknown with the other number. So in this case, I will write 42 sine of m. Not that it really matters, it's a matter of preference. So 35 sine 58. Again, I need to isolate the unknown, and the unknown in this case is the sine of m. And we are going to say that, need to isolate sine of m from 42, so divide both sides by 42. Next thing you want to do is write sine of angle m equals 35 sine 58 over 42. Now remember, you're not finding the sine ratio. We are finding here actually the angle itself. So one more step here. We're going to write angle m equals inverse sine, and then 35 sine 58 divided by 42. So I'm going to go to my calculator now and evaluate this expression. So I'm going to go 35 sine 58 over 42. So we'll go second sine 35 times sine 58 divided by 32, we said, and close the brackets, and 68 degrees, 68.056, let's see, to the nearest degree. So angle M is 68 degrees. And this would be our answer, which we are going to box it up. And again, if you were asked to find other measurements, so this is 68, then we are going to say that we simply use the formula here for the sum of angles in a triangle formula to find P. And we have to use the sine law one more time to find the side length P. So, sorry about this. This is the lesson for today. So what we learned was the sine formula. We emphasized the fact that the sine law formula can be used in non-right angle triangles. And we also emphasized that SOHCAHTOA can only be applied in right angle triangles. And we went over an example where we had to find a side length using sine law. And we went over an example where we had to find the angle by using the sine law. I hope everything made sense, and see you again next time.